Welcome to this class. Today I am starting a new chapter wave of class 9 and it is taken in unit 10 and the subject is science and technology. And today our focus is on wave, transverse wave and longitudinal wave. But before starting this class, I want to tell you some common experience about the television and remote. Look at this. Whenever we have to run our television, then we'll push the button of the remote control. And because of this pushing of the button of the remote control, television screen opens. And according to the requirement, we can change the channel also pushing the button. What is it exactly? How these two are connected? Remote control and this TV set, they are connected by means of wave. Look at this is a tower and this tower is continuously releasing the radio waves, tele waves, which when we get in our television, then television works and this radio set can produce sound. This way, this is also related to wave. And this is also the same and this one also the same. We are showing the wave broadcasted by the radio station and tele station and which comes to our television set and radio set, and this radio set and television set works. In all these cases, wave is working, wave is utilized. Now look at this another case. In this case, actually wave is transmitting from one place to the another place, from this three end to the another end which is tied at certain point. And wave is transmitted to this place by means of the particle of the rope. Look at this another one. This is also the representation of a kind of wave. Wave is being produced at this point and it is transmitted towards right hand side this way, and this red part represents the electric field and this blue part represents the magnetic field, and this wave consists of electric field and magnetic field. They are produced right angle to each other and they are periodically changing their position also. This is electromagnetic wave. Light comes from sun to the earth or light travels from one place to the another place by the help of this electromagnetic wave. I mean to say, the method of transmission of light is electromagnetic wave. In the same way, I want to show another also. Water is taken in a bowl and few drops of water is dropped in the middle part. The ripple of water produces, and this ripple of water reaches up to the edge of the bowl in which water is taken, and this ripple carries energy from central part to the edge of the bowl. This way, actually, a wave is carrying energy from one place to the another place through water. At this time, water acts as medium. Here, rope acts as medium. But in other cases, wave doesn't require any material medium for transmission. This and this case. In this case, wave is not transmitted by any material medium. This is the same. Water is periodically disturbed by certain object which produces ripple of water, and this ripple of water is carrying energy from this place to the edge of the pond. And another example, this is the surface of the sun and solar flare is being produced, and because of this region, solar energy is transmitted from sun to all the direction and it comes to the earth in the form of light and heat energy by the waves. And this is seismic wave, I mean to say earthquake wave. This is fault of fracture, and when fault of fracture collide with each other, the fault of fracture is appeared in this earth crust, and in earth crust, because of this fault of fracture, when they collide with each other or glide over each other, then earthquake comes, and earthquake comes up to the surface of the earth in the form of seismic wave. I am talking all about the wave. Actually, in every case, we are related to the wave. In some cases, wave requires material medium for transmission. in some of these cases, wave does not require material medium for transmission. It means in all these cases, wave transmits energy from one place to another place. But somewhere it requires medium, somewhere it does not require medium. Now, I want to talk about the mode of transfer of energy is only wave. No, there are two modes of transfer of energy. One is motion of the body. Energy can be transmitted from one place to another place by the real motion of the body. And energy can be transmitted from one place to another place by the wave motion also. And real motion of the body means if a body is thrown or if a body is moving from one place to another place, it carries energy from one place to another place. This is the method of transmission of energy from one place to another place. And this can be understood very clearly with this example. Look at this. A ball is thrown on the glass and it carries energy up to the glass and the glass breaks. The moving body carries energy from one place to another place. Look at this another one. When a fast moving object strikes this wine glass, then wine glass will break. The moving object carries energy from one place to another place. And second method of transmission of energy from one place to another place is wave motion. Wave carries energy from one place to another place. That was explained in this example also. When wave produces on the surface of water, then energy transmits from this point to the edge of the container if this water is taken in the container. This can be easily understood with the help of this diagram also. If a stone is thrown in a pond, then ripple of water produces. That means the wave produces on the surface of the water, and this wave transmit energy given to this point to the edge of the pond. We can see the edge of the pond is hit by the water ripple. This is the transmission of energy from central part to the edge of the pond. That's why we can conclude that there are two modes of transfer of energy. One is by the motion of the body and second is by wave motion. Now, I want to define this wave. What is wave exactly? We can say this way. Wave is a periodic disturbance that transmits energy. Periodic disturbance which transmits the energy. Just before this diagram was shown, when water is periodically disturbed. Periodic disturbance means if a body is moving this way from mean position to extreme position and again returns back to mean position and goes to extreme position of another side and comes back to mean position. This way, if a body keeps on moving this way, then this is called periodic motion. Or maybe like this also, periodic motion. Repeatedly similar motion if appears in a body, that is called periodic motion. If a source, just for example, our vocal cord or maybe the bell, ringing bell, this produces periodic disturbance in the air. And because of this periodic disturbance produced in the air, sound wave produces in the air and it travels from one place to another place. That's why we can say that wave is a periodic disturbance that transmits energy. We can define wave this way also. Wave is just the carrier of energy. If there is no any medium, even then, wave transmits from one place to another place. From the sun to the earth, light is coming. This is the transmission of wave without any medium. That's why there is no any disturbance in no any particle. That's why wave is the carrier of energy. This is simply definition. Now wave is of two types. One is called mechanical wave. Another is called electromagnetic wave. Wave is divided into two types. One is mechanical wave. Another is electromagnetic wave. Now what is mechanical wave? The wave which requires material medium for propagation is called mechanical wave. If a wave requires material medium to go from one place to another place, to transmit energy from one place to another place, if it requires material medium, then this wave is called mechanical wave. We can see this animated picture. Look at this speaker is moving. and forward and backward. The surface of the speaker is continuously moving and it pushes the air particles forward, and when the speaker comes back, the same air particle is pulled backward because the air particle moves along with the surface of the speaker, forward and backward. If you observe it carefully, then particles are moving once away from the speaker and again it comes back towards the speaker. This way it keeps on moving forward and backward. This is periodic motion of the particle, and that's why the wave, if produces in a medium, the periodic motion of the particle of the medium appears and it propagates in the form of what? Longitudinal wave or transverse wave. Later we'll talk about the longitudinal wave and transverse wave, but this type of wave which requires material medium for transmission is called this mechanical wave. Okay, let's talk about this mechanical wave a little more nicely. It is a form of disturbance that produces repeated periodic motion on the particles of the medium about their mean positions, and the disturbance is handed over from particle to particle, due to which wave produces and travels through the medium. It is an elastic wave. Actually, mechanical wave, when produces, one of the particle pushes another particle. Pushes another particle means it handovers the energy to another particle and comes back. The handovered energy is now taken up by the second particle. It pushes the another particle and hands over the energy. It hand over the energy to another particle that moves forward. This way, particle to particle energy is handed over, but particle keeps on moving along its mean position. Now another type of wave is electromagnetic wave. What is it? The wave which does not require any material medium for propagation is called electromagnetic wave. The wave which travels in the form of electric and magnetic field and does not require the material medium to travel is called electromagnetic wave. And how it travels? This figure previously shown, the wave is traveling towards this direction. It means energy is transmitted towards this direction, but in the form of electric and magnetic field. Red part represents electric field, this blue part represents magnetic field, and they are right angle to each other, and their position is being changed within fraction of second. In this way, from the source, if the energy transmit to another part in the form of electric field and magnetic field, in this way, right angle to each other and periodically changing their position, then this type of wave doesn't require any material medium for transmission, and this is called electromagnetic wave, which can be written shortly like this. It is the wave produced by the mutually perpendicular and periodically varying electric and magnetic fields in a plane normal to the direction of propagation of wave. I told you about electromagnetic wave and I told you about the mechanical wave. Now, electromagnetic wave comes later. I'll tell you about electromagnetic wave in next class, but we are continuing the mechanical wave. There are two types of mechanical wave. They are transverse wave and longitudinal. Now let's go through transverse and longitudinal. What is transverse wave? Transverse wave can be understood this way. Okay, look at the board. Let's say these are the particles of the medium. Let's say this is water surface and the particle of water surface is not moving. When transverse wave produces on the surface of water, once the particle moves forward in the upper side and reaches to maximum displacement, reaches to the extreme position which lies at the upper side, and it comes back and goes down to another side, extreme position of another side. Again it comes back to the mean position. This way one vibration is completed by the particle. It starts to move from mean position and goes to extreme position of one side and comes back to mean position and goes to extreme position of another side, again comes back to mean position. This way one complete vibration is made. All the particle keeps on moving the same way. If the particle keeps on moving the same way up and down, but the wave travels in this direction and particle keeps on moving up and down this way, then this type of wave is called transverse wave. What it is? The wave, the mechanical wave in which the particles of the medium vibrate perpendicular to the direction of propagation of wave is called transverse. This way we can define transverse wave. But look at this animated video. In this case we have to observe this red dot mark, red point. It keeps on moving up and down, up and down. Everywhere we have seen this red dot mark which keeps on moving up and down, but they never leave their mean position. They are moving up and down only, but wave travels in this direction. I mean to say, wave is traveling towards this direction, energy is traveling towards this direction, transmitting towards this direction, but particle of the medium is moving up and down only. This type of wave is called transverse wave. We can define this way. A mechanical wave in which the particle of the medium vibrates perpendicular to the direction of propagation of wave is called transverse wave. For example, wave produced on the surface of water is transverse wave. With the help of a spring also we can show it very clearly. If this part of the spring is moved up and down, then what type of motion is seen in this spring? The spring carries energy towards this direction, right hand side. Energy is passed towards this direction, but the part of the spring is moved up and down. It represents transverse wave. This example shows the transverse wave. This way we can understand transverse wave. Now let's talk about longitudinal wave. Now how can we understand about this longitudinal wave? Okay, I want to show it with diagram. Let's say we have a particle here and it is moving in this way. It reaches to maximum displacement, the extreme point at right hand side, and again comes back and goes to extreme point of left hand side and again comes back to mean position. Then it made one complete vibration. One complete vibration is made by this particle. And if the wave travels in this direction, if wave is also traveling in the same direction and particles are also moving along the same direction, back and forth motion of the particle produces wave in the same direction, then this type of wave is called longitudinal wave. We can understand with the help of this animated video. Because this a source, when disturbs the particle of the medium, particle moves forward and it hand over the energy to other particle and comes back. That also moves forward and hand over the energy to other particle and comes back. This way particle keeps on moving back and forth, forward and backward, but energy is transmitted to the right hand side, I mean to say this direction. The direction of transmission of energy is this, and motion of the particle of the medium is also along the direction of propagation of wave, and this type of wave is called longitudinal wave. That's why we can define this way. A mechanical wave is called longitudinal wave if the particles of the medium of the wave vibrate along the direction of propagation of wave. This is called mechanical wave. For example, sound wave. Sound wave is mechanical wave. Now I want to differentiate the sound wave, longitudinal wave with the transverse wave. Look at this. This first animation represents the transverse wave and second animation represents the longitudinal wave. In transverse wave, particle moves up and down, but energy is transmitted towards this direction. Wave is traveling towards this direction. But in longitudinal wave, the particles are also moving in the same direction, back and forth, front side and back side. It is moving forward and backward, and energy is also transmitted towards the same direction. This type of wave is called longitudinal wave. This way we can differentiate transverse wave and longitudinal wave with the help of the spring. Now let's talk about the differences between the transverse and longitudinal wave. The major difference first is certainly definition. The particle of the medium vibrate perpendicular to the direction of propagation of wave in case of transverse wave. But in case of longitudinal wave, the particle of the medium vibrate along the direction of propagation of wave. Second difference is it produces in the form of crest and trough. Do you remember what is crest, what is trough? I want to show this. Look at this, represents crest and trough. This is the mean position of the wave. The part of the wave produced above the mean position is called crest, and the part of the wave produced below the mean position is called trough. And transverse wave forms in the form of crest and trough. But longitudinal wave, it is different. It forms in the form of compression and rarefaction. What is it? Compression and rarefaction. When sound wave produces in air, at certain part of the air, the particles of the air comes closer to each other, and that part, that region of the wave is called compression. At other place, the particle of the medium, particle of the air moves away from each other, and that region is called the rarefaction. And sound wave travels from one place to another place in the form of compression and rarefaction. Looking at this diagram, we can understand easily. When sound wave travels from one end to the another end, this end to this end, then it forms in the form of compression and rarefaction. Compression is the region where the particle of the medium are close to each other, and pressure at this region is more, density of this region is also more, and the region at which particles are moved away from each other is rarefaction, and in this rarefaction the pressure of air is less and density of the air is also less. And distance between two successive compression or two successive rarefaction is taken as wavelength. Wavelength you are taught in class 8. Just I mentioned this here. This is written here. That's why only I mentioned this. Otherwise, we have learned about this in class 8. The distance between two successive compression or the distance between two successive or neighboring rarefaction is wavelength. And longitudinal wave transmit in the form of compression and rarefaction, but transverse wave in the form of crest and trough. Another difference, it propagates only in solid and on the surface of the liquid, but the longitudinal wave, it propagates through solid, liquid and gas. It propagates through all the medium, whether it is solid or liquid or gas. This is another difference. And another difference, there is no any variation of pressure in this wave. In this case, there is variation of pressure. In compression, pressure is more, density of the particle is more, but in rarefaction, density and pressure of the particles will be less. These are the basic differences between transverse wave and longitudinal wave. Now I want to present one question. It verifies whether your understanding about the transverse wave and longitudinal wave is clear or not. Look at this statement. All the types of transverse wave requires material medium for propagation. Is this correct? Just think about this. Now one argument is added on it. Transverse wave travels in the form of crest and trough. Is this correct? Just think about this also. Now another argument is also given. In the mechanical transverse wave, the particle of the medium vibrate perpendicular to the direction of propagation of wave. Looking at all these, we have to select one of the option. Either first or second or third or fourth. Number 1, only statement is correct. Is it? all the types of transverse wave requires material medium for propagation. This is not correct because the electromagnetic wave is transverse in nature, because electric field and magnetic field are produced right angle to each other. Its nature is transverse. That's why electromagnetic waves are transverse wave. And here what is written, all the types of transverse wave requires material medium, electromagnetic wave doesn't require any material medium. That's why this statement is not correct. So the option number 1 is not correct. Now let's go through option number 2. Only argument 1 is correct. Argument 1, transverse wave travels in the form of crest and trough. Is this correct? Yes, just before this I told you about this. Actually transverse wave travels in the form of crest and trough, whether it is mechanical transverse wave or it is electromagnetic wave. It travels in the form of crest and trough. Now this only argument 1 is correct is written here, but maybe argument 2 is also correct. That's why we have to go through argument 2 also. So let's see the third option. Statement and argument 2 are correct. This is not correct because previously it is decided that statement is wrong. That's why the option number 3 is incorrect. So I don't want to check this option number 3. Now let's go to option number 4. Both the arguments are correct. Is this? Now argument 1 is correct, previously decided. Argument 2, in the mechanical transverse wave, the particle of the medium vibrate perpendicular to the direction of propagation of wave. Is this correct? In mechanical transverse wave, particle vibrate perpendicular to the direction of propagation of wave, right angle to the direction of propagation of wave. Yes, this is correct. That's why the option number 4 is correct. Both the arguments are correct. Okay, now let's move on to another part. I mean to say another type of question. Find the correct and incorrect arguments from the following. Here I'm going to show you some arguments. Some of them are correct, some of them are incorrect. You have to evaluate them and you have to decide which one is correct, which one is incorrect. Sound wave is a longitudinal wave which travels in the form of crest and trough. Evaluate it. Now pressure and density is high in the compression of the longitudinal wave. Now think about this also. Mechanical and electromagnetic wave both carries energy. Is this correct? Okay, another one. Distance between compression and rarefaction of longitudinal wave is the wavelength of that wave. Okay, these are the arguments. Now check it out. Number 1, sound wave is a longitudinal wave. This is correct. Which travels in the form of crest and trough. This is incorrect. The later part is incorrect. That's why the argument is incorrect. Pressure and density is high in compression of the longitudinal wave. Yes, in the compression, particle comes closer to each other. That's why pressure is high and density of the medium will also be high at that place. So this argument is correct. Mechanical and electromagnetic wave both carries energy. Yes, wave is the carrier of energy, whether it is mechanical wave or electromagnetic wave. It doesn't make any difference. All the wave carries energy. In the definition, we have learned that wave is the carrier of energy. That's why this argument is correct. Distance between compression and rarefaction of longitudinal wave is the wavelength of that wave. Distance between compression and rarefaction is told. This is incorrect. Distance between the compression and neighboring another compression, distance between the two neighboring compression or two successive compression or two successive rarefaction is the wavelength of the longitudinal wave, not the distance between compression and rarefaction. That's why this argument is incorrect. Okay, I think I told you many matter related to transverse wave and longitudinal wave in detail, and this class will help you to understand the subject matter. Now we'll meet in another class with some another matter. Thank you.